dear students of class 12. Today we will be continuing with the third chapter. In fact, we are going to start the third chapter, that is electrochemistry. So in class 10, that is your ICSE level, you have studied about electrochemistry, not electrochemistry, electrolysis. Okay, so in electrolysis, what happens is, here the externally supplied electric current is used to bring about a chemical reaction. So in case of electrolysis, we are supplying electric current from outside to bring about a chemical reaction. That is in electrolysis. But in electrochemistry, it's just the opposite. It's just the reverse. In the sense that here we carry out a chemical reaction and the energy produced of this chemical reaction is converted to electrical energy. Hope this is clear now. So electrochemistry is just the opposite of what? Electrolysis. Here the energy of a chemical reaction is converted to electric current or electrical energy. So let's discuss about electrochemistry then. So let's discuss about galvanic cell. So in case of galvanic cell, what we have? We have zinc and copper electrodes. So this cell, galvanic cell or Daniel cell, is made out of what? Zinc and copper electrode dipped in its solution. Okay, so let's have a rough sketch of how this cells it works. Now this is just a rough diagram. Now here this electrode is dipped in its solution and this electrode is also dipped in its solution. Okay, now these two are electrodes and this electrolyte is set, and you have what? Electrolyte in which this rod is dipped. Now here this rod is zinc and this electrode is copper. Okay, now this zinc is dipped in zinc sulfate solution and this copper is dipped in copper sulfate solution. The reaction that takes place in this particular cell is zinc reacting with copper, zinc reacting with copper ion to give you zinc 2 plus ion plus copper. So here you have to remember one thing, that in such cell always redox reaction takes place. What takes place? Redox reaction. One of them will be oxidized, the other one will be reduced. So zinc in this case is being oxidized and copper is being reduced to copper. So this is reduction process and this is oxidation process. Okay. Now zinc is present here. Now since it is being oxidized, means it will have excess electron over there. That means whenever zinc is being converted to zinc 2 plus ion, that means it leaves behind electron. Therefore, this terminal is negatively charged. It's negative. Why? Because we have, whenever this zinc is oxidized, it leaves behind electron and electrons are negatively charged. Likewise, this is positively charged. Okay? Now, these two, this individually, this zinc dissolved in zinc sulfate is half cell. It's what? It's half cell. Similarly, this is also copper dissolved in copper sulfate is another half cell. Now these two half cells are connected by a bridge. Okay, these two are connected by a bridge which is known as what? Salt bridge. We call it as what? Call it as salt bridge. And this side oxidation takes place. Therefore, this is anode and this is cathode. So for remembering purpose, you can always remember this form as simple alphabet. Okay, like A, B, and C. A for anode on the left hand side. In between you have bridge, and on the right hand side you have C, that is cathode. Hope this is clear now. In anode always oxidation takes place. So what takes place? Oxidation, and in cathode reduction takes place. Hope this is clear now. Now, in this case, what you have to remember is whenever these two terminals, anode and cathode, is connected externally. Okay, if it is connected externally, suppose here you have a key. Okay, now if this key is closed, that means this key now is closed, then what will happen? Now it makes a complete circuit. Now what will happen? Electrons from this anode, that is negative excess of electron is there. Now it starts flowing towards the positive side. Once the electron starts flowing, then what we obtain is we obtain electric current. What we obtain? The flow of, what is electric current? Electric current is just the flow of electrons. So once this circuit is closed, this key is closed, and what happens? The excess electrons on the side will start going to the other terminal, other electron. Then what will happen? The electric current will be generated. And you know the conventional direction of current is always opposite to the direction of flow of electron. Electron here is flowing from left to right, and the direction of current will be from this right side to the left hand side. This was taught in your lower classes. Now this is how an electrochemical cell works. Now such working takes place. Can you give me some common example? Can you tell it? Where you are using this chemical reaction and you are generating electric current. Can you get it? Yes. It's the batteries, the cells, the batteries. There what happens? The reaction takes place within the battery, and because of that, what we obtain? We obtain current. Okay? Now let's discuss about cell notation. Cell notation is very, very important. Symbolic representation of cells. Now, since we are discussing about galvanic cell, let's discuss how this is represented. Now we are going to discuss about symbolic representation of galvanic cell. Symbolic representation of galvanic cell. So if you understand how this galvanic cell is represented, okay? There is an IUPAC way of representing it, and for all other types of cell, the same order will always be followed. Now you have to remember that on the left hand side, always anode is written. Okay, as you had here just now, anode A, B, C. So here also anode on the left hand side. Then in between bridge, you have bridge. Then you have cathode. So just now we have discussed about this galvanic cell. Now on the anode, you know what takes place? Oxidation takes place. And cathode, you have what? Reduction taking place. And in a way, you can represent it by what? ABC. I told you A, B, C. So it's so simple. Alphabetical order A, B, C. Now, in case of galvanic cell, what we have? We have zinc and copper dissolved in its respective. There is a sulfate solution. Here, this can be represented in different manner. Now, suppose you have anode oxidation taking place. So, what was used as anode in case of zinc copper, that is galvanic cell? Zinc was used as anode. Therefore, zinc is written now, and you can use a line to represent it, and zinc was being oxidized to zinc 2 plus, isn't it? It was being oxidized, therefore it is used as what? Anode, oxidation takes place. So zinc being oxidized to zinc ion, or instead of this line, you can also use semicolon. Zinc semicolon Zn2 plus. Now this bridge is always denoted by a double line. Please don't forget, bridge is always denoted by a double line. And in cathode, what takes place? Reduction. So cathode was made of what? Copper. So reduction taking place at cathode is denoted as copper 2 plus gaining electron to become copper. Or instead of writing this line, you can also use semicolon to separate these two neutral atom and the ion. So this process, copper ion going to copper is what? Reduction. So this is how it can be represented. Or instead of ion form, we can also write this in this electrolytic form. For example, zinc dissolved in zinc sulfate, this electrolytic form, and you can also mention the concentration of this electrolyte. Like if it is say 0.1 molar, you can mention that within the bracket. Okay? And bridge again, it will be represented with the double line. Similarly here, since you just copper, you can also write copper sulfate, and you can mention its molarity. Suppose its concentration is 0.2 molarity, then it can be mentioned in the bracket, and here it can be separated by a line, and you will get copper. And instead of these lines, like here you used semicolon, here also you can use semicolon. If you use semicolon, you have to use on both sides. Here you use semicolon, here also use semicolon. If you use a single line over here to separate these two, here also it has to be used a single line. Okay, so this is how a cell is represented IPAC in IPAC way, and you have to remember this. This is very important. Now in your book you have more other examples. Okay, more other examples. Please refer to it properly because this is very important. Here the questions will be asked. Now from this you can get the chemical reaction. How does the reaction take place? Now see, from this notation, zinc is being converted to zinc ion. That means on the left hand side we have zinc reacting with, on the left hand side what we have? Copper 2 plus. Now this zinc is being converted to zinc ion Zn2 plus. Now this copper 2 plus ion is converted to copper, therefore copper has to be written here. Now from this is one half cell, this is another half cell. Now whenever you connect them together, you get one full working cell. And the reaction of that full working cell is what? This particular reaction. Now here you might be asked to write this reaction from cell notation, or reaction will be given and you have to write the cell notation. Any of the two way can be asked in your examination. Please learn this properly. Now let's move on to the next topic. So let's discuss about standard hydrogen electrode. Okay, so we are going to discuss about standard hydrogen electrode or normal hydrogen electrode, SHE, or standard hydrogen electrode, SHE, or normal hydrogen electrode. So this is like used as a reference electrode. For example, now if I have to give you a common example, then whenever you go for buying some amount of, say, vegetable or some fruits, then what happens? In market, we have this pan system, spring balance, the measuring balance here, which is used, in which we have one standard, like 1 kg standard is there. Now that standard is kept over there, and against it the amount of substance like fruit, if you need it, it is measured up in reference with that 1 kg this pen. Yes or no? This 1 kg standard. Are you? Please try to get it. There has to be some reference standard has to be there. Like you have, if you want to buy 1 kg, you went to the market, you ask for 1 kg, say apple, then they will put 1 kg in one pen, and against to that they put some apple in another pen and they measure it and they give you. Yes or no? Now that 1 kg is what? The standard for measuring this apple. Similarly, whenever we come to potential, please now listen carefully. Whenever we come to measuring potential, measuring absolute potential of any single half cell is impossible. It's impossible. So it has to be referred to some standard. Here, SHE, standard hydrogen electrode, standard. Remember, normal hydrogen electrode is what? Is the standard or the reference electrode where the potential of other these half cells will be compared. Now it is used as a reference. So it has to be compared with that. Then we say that some of the half cell has more potential, the others has less potential. So this SHE is nothing but standard hydrogen electrode, and it is used as a reference electrode. Please remember that. And in the book you have the definition. You have to remember this. Okay. Now let's discuss about single electrode potential and its measurement. Just now I told you, it is impossible to measure the absolute electrode potential of a given half cell. So it has to be compared with what? Some reference electrode, and this reference electrode is what? SHE, or normal hydrogen electrode. Okay? So you have to remember this, and by comparing with this standard hydrogen electrode, like you have anode, cathode, you have similar, you have anode, then you have cathode. Now this hydrogen has to be kept as one standard, and the other half potential will be compared with it. Now it might have, it might have positive potential value or negative potential value. Okay, and this is very important. Now from knowing the value of electrode potential, okay, by comparing it with this standard hydrogen electrode, we come to know whether it acts as anode or cathode, and this is very important. This is positive value and negative value. Please listen to it very carefully. Significance of sign of standard electrode potential. Now please listen to it very carefully. Okay, if E naught, that means standard electrode potential value is positive. If E naught, standard electrode potential value is positive, then what will happen? This half cell, okay, this half cell will act as what? Cathode. It will act as cathode. It will act as cathode, and in cathode, you know what takes place? Reduction takes place. Okay, if E naught is positive, now what is E naught? E naught is like naught means standard. Everything has to be, the space is present in that particular, this electrode has to be in standard condition, and EMF of that is known as what? Standard electrode potential. Now if E naught is positive, then this particular half cell will act as what? Cathode, and reduction takes place. And if E naught is negative, then what will happen? This will act as anode, and in anode you know what takes place? Oxidation takes place. What takes place? Oxidation takes place. Okay. Okay, let me read it out from the book. Say, if E0 for an electrode is positive, it means that the electrode under standard condition is more positive than SHG, so that reduction occurs at this electrode, cathode, and oxidation occurs at SHG anode. So whenever you have this E0 value as positive, then your this standard hydrogen electrode will be placed where? Will be placed as anode here, SHG will be placed here, and whatever you are using it will be placed as what? Cathode. Okay? Will be placed as cathode. You have to remember this. Like copper. Copper will be placed here. Okay? Why? Whenever E0 value is positive, then copper has to be placed as cathode and SHG will occupy this anodic position, anode's position. Similarly, if you have E0 value as negative, then anode will act as anode and oxidation takes place. Now in this case, this is the first case. This is the first case, positive case. Standard hydrogen electrode will act as anode because the other one is acting as what? Cathode. Now if it has to be the other way, if E0 is negative, then what happens? This electrode will be as anode. That means you have anode here, and in between you have bridge. This is bridge, and you have what? Cathode. Now this negative value tells us that this now SHG will be acting as, will be placed where? Will be placed at cathode, and like if you say zinc will be placed as anode. Okay, so you have to remember this. Positive SHG is going as what? Anode. If E0 is negative, then standard hydrogen electrode is placed at what? Cathode, and this is very important. Okay, so the standard EMF of a cell is what? Now EMF of the cell, when all the spaces are in standard units, or their activity is unity. You have to remember this one also. Now on your book, on page number 312, you have standard electro reduction potential given for so many metals. Okay, your work. You can look at it. Now it's very difficult to mention all these items. It will not be enough here. So please refer to page number 312. You have here standard electrodes, and within the bracket you have reduction potential for different metals. Now you can see fluorine F2 going to F minus, means here its electrode potential value, its standard electrode potential value is 2.87, which is at the top, and it is positive 2.87. And as you go down, for all the metals, it keeps on decreasing. It becomes 0 for hydrogen H plus / H2. It becomes 0. From highest value, it has decreased. It has come to 0, and 0 is for what? Hydrogen. Please remember, 0 is for hydrogen. And as you go down, it starts becoming negative, more negative, and the last one is K plus K, whose value is minus 2.90. Now, what does it mean? It means that here, this system, standard electrode potentials of these particular metals and other species are arranged according to their what? Increasing strength of oxidizing agent. Means, as you move from top to bottom, their tendency to act as oxidizing agent will increase. So in a way, you can remember this way. This is how I used to remember it. As you go from top to bottom, the value of E0 keeps on decreasing. Highest decreases 0, then it becomes negative, and the most negative means the lowest value is at the bottom. Okay? Now, the lowest value is at the bottom, means more negative. So remember this way. If the electrode potential, standard electrode potential value of some of the species is more negative, in a sense you can remember that remember in a way that they have more electron, negative is related to electron, so they are always willing to give up the electron. So they are always willing to give up the electron. More negative, they are willing to give the electron. Okay, so if they are willing to give up the electron, means they are acting as what? They are acting as strong oxidizing agent. This, if you keep this in your mind, you will be able to tell which one will be acting as anode and which one will be acting as cathode from this particular reduction standard reduction potential values. So remember this way: more negative, they are willing to give up the electron. Yes. Now, if they are willing to give up the electron, giving up of the electron is what? Oxidation. Oxidation. So where does the oxidation take place? Anode. So more negative or smaller the value of standard reduction potential, they will be acting as what? They will be acting as anode. And the other one has to act as what? Cathode. So in a cell, you have two reactions, two half cell reactions. So these are all half cell reactions and their potentials are given. Now, from the standard reduction potential value, now you know, lesser the value, they will be willing to give up the electron, they will be acting as what? Anode. And the other one, which has higher value of this standard reduction potential, they will be acting as cathode. So if you remember this, then most of the problems you will be able to solve it. Okay? Most of the problems you will be able to solve it.